Hello, good evening everyone. I welcome all of you to Gradeup channel. Yes. Good evening everyone. So today's session is about our shear force and bending moment. I hope I'm audible to all of you. Let us join quickly. Let us join quickly for today's session. Okay. Share it and oh, it's not. Oh. Am I audible to all of you? I can see the chat box now. A very good evening to everyone. Let us start our session quickly. So once again welcome all of you to Gradeup channel for YouTube in a champion study plan. Hello Mag. This is one of the most efficient plan for GATE 2022. You will go if you'll go to the description box, you'll get the benefit, maximum benefit from the description box. You have a link, go to that particular link, notes are available, quizzes are available, so many things are available. So just get the schedule, the notes, books, everything, right? This is my small introduction, and you can join me on Telegram, which is nothing but Civil by Ansari Sir, isn't it? Civil by Ansari Sir, in bracket maybe the surgeon it is written. You can join there. There is a batch is going on for GATE and ES Vision 2022 and 2023, both in English and Hindi. These are our star faculty of the Gradeup. There is a GATE 2022 champion study plan which I was talking about. This is one of the most efficient plan for 120 days free of course for GATE. You please take the benefit from here, right? Including app classes, the theoretical classes in app, and the practice session in YouTube, and along with the notes which is available there, you take the maximum benefit of this plan. Hello Diksha, hello Mohit, hello Krishna. There is a mega mock challenge on 29th August for Bark. You can sit for that. Now this is the first problem. Someone asked me the problem related to some question which I believe that if you will be able to solve this problem, you will be, oh I'm sorry, you'll be able to understand it. Can you solve this one? Can you solve this one? Is it visible to you? Is it visible to you? This is just, fancy diagram. Nothing in this problem. This is just a fancy diagram. That's all. Nothing is there in this diagram. In this question. Question is very easy. Can you solve this one? Someone actually asked me to explain. So I just created one problem related to that. If a member is kept vertical as shown in figure, then what will cause by moment mx and my respectively. If you are applying mx and my, if you will understand what is the meaning of mx and my, these two are the fixed location. The beam or the member is fixed in these two positions. If now you are applying mx, what is the meaning of mx? You should understand that the moment which is rotating about x-axis is your mx. The moment which is rotating about y-axis is called my, and the moment which is rotating about z-axis is called your mz. This is your mx, this is your my, and this is your mz. Now if you'll apply mx, what will happen to this one? If this is fixed at both top and bottom, vertically kept here, mx will produce a deflection in which axis? About the deflection of the bar will happen, or the beam will happen in z direction. Agree or not? In z coordinate direction the deflection will happen. Then due to my, you are not applying mz here as per the question, you are applying mx and my. If you will apply my, what will happen? So my will actually produce, see, this is the axis. If you will apply the my, are you able to understand that? If you will apply the my, see, my will create a torsion in the beam. Agree, no? Agree or not? So my and mx, if you are applying, mx will produce deflection in that direction, my will produce a torsion. That's all. That's all. If you will apply mz here, what will happen? You can see that one also. Although it is not there in the question, if you will apply mz, so mz, what it will create? Mz, it will create deflection in the x direction. But here you have applied mx and my, which will create deflection in z axis and torsion is not given. Okay, deflection in z axis and a twisting, that torsion and twisting of the beam. That's all. Did you get that? So there was a student who asked me regarding that. Now you are, maybe I hope you are able to understand that how the twisting and bending can be understood with the mx and my. Now beam is given here. Is it visible to you? The beam is given here. Beam AB will be subjected to. The beam AB will be subjected to. What will be the answer for this one? The beam AB will be subjected to. Yes, I'm just waiting for your comments. Okay. It is quite simple, no? Just to shift it. Shift the P. See, although you can do it in a different way. There are always several ways to do that. Here, what I suggest, you can shift the load simply. Yana? If you are shifting it here, what you will get? P into C. P into C. This is your direction of your. This is your direction of bar. So you will get a moment which is nothing but your value of the moment is P into C, right? Then you will get P. So you have shifted it here. Shift it once again. So PC will be already can be pushed there. Along with that, P will be acting downward. Shift it once again. That P will be coming here, and P into B, a moment will be created here. That P into B moment will be created like this. P, if you stand here, what this P is doing, it is going to create a just a second, I'll create a nice diagram so that you will understand clearly. This is the moment which will created by the P into B. P into B. Then P into C, you push it directly. P into C will directly come like this, and P is already applied here. So AB will be subjected to what? The beam AB will be subjected to PC, PB and P. PC and P will create bending over the beam AB. PC and P will create bending over the beam AB, and PB will create the torsion. And PB will create the torsion over here, isn't it? Are you able to understand that? And P will create the shear also. So for beam AB, these are the forces you will be getting it. So understand it how to shift the forces. Now the question is, for the given loading, the distance from left hinge support where the shear force will be zero. How will do this one? From the left side of the support, left hinge support where the shear force will be zero. How will do that? First of all, you should be able to draw the shear force diagram. Before drawing the shear force diagram from this particular loaded beam, what I'll do? I'll first of all shift the load here. That 10 kilonewton, if you'll shift it here, what exactly you'll get? If you'll shift the 10 kilonewton here, what exactly you'll get? a 10 kilonewton will be applied here, and 10 into 3, that 30 kilonewton meter moment also will come if you are shifting that one. So over the beam now you have you have that axial 10 kilonewton, which is not going to create any trouble for us to get the vertical reaction. Now what is the vertical reactions you will be having? So you have a UDL, that UDL will create, so UDL 2 into 6, that 12 is the total vertical load due to the UDL. 12 divided by 2, that is 6 and 6 you are going to get due to the UDL. Then you have a net moment which is 30 kilonewton, right? So what will be the reaction due to the moment? What I told you, draw the two lines, and you see that what is the direction of your net moment. The direction of net moment is clockwise, so the reaction will be generated in such a way that they will rotate anti-clockwise. To oppose the moment, the net moment. Now net moment is 30 divided by length of the beam, 30 by 6. What is the final reaction you have? 5 downward, 6 upward. So you'll get finally 1 upward here, and finally you'll get 11 upward here. Are you able to understand that? This is the reaction, final reaction you have. Now if you draw the shear force diagram, what exactly you'll get? Draw the shear force diagram for this one. So now stand nearby that. If you'll see that 11 is acting upward side, if you'll stand here, 11 is rotating about you in a clockwise direction. Okay, no, it is rotating in anti-clockwise. Okay, if you are standing, just a minute, I'll take another color, you'll understand it. Yes, if you're standing here, now this 11 is rotating about you in anti-clockwise, so minus of 11 you'll get, isn't it? Then if you'll stand here, 6 is rotating about you in a clockwise, so plus 6 you'll get, plus 1, reaction is plus 1, very small. So you'll get only 1 plus here. Now in between, if you see here, you do not have any transverse load. You have axial, that is 10 kilonewton, and you have a moment and axial will not disturb you in your that shear force diagram. So you are going to get like this. Now you have understood that somewhere here you have a shear force 0. So consider the section somewhere here. You can do that with the help of similar triangle, or you can just consider the section. Both methods are okay. Either you solve it through the similar triangle, or you solve it by considering the section at this location. Now if you write down the shear force at the section X, what is the shear force at section X? I have 6 rotating about me. I'm standing here, so rotating about me in a clockwise. So plus 6 I'll consider. Sorry, once again mistake. No, this final reaction is 1. I'm sorry, once again. Plus 1, and then you have, do not forget, these two have added together. Then I got this one. Every time I'm committing a mistake. So now plus 1, and then UDL you have, that is 2 kilonewton per meter for the X distance. So I'll write down minus of 2x is the total load. So that is the definition of summation of all the transverse load. Please provide us the notice where whatever I read in this entire live. Notice means? Mohit, I didn't get that. What you're talking about? Notes. Okay. Today you will get it for today, and yesterday whatever I have conducted, both I will provide it today. In my Telegram channel, I'll provide. I think I have provided already, no, for yesterday. For today also I'll provide it. So SFS, now this will become 0. So X you are getting 0.5. From the left side, it is at 0.5. Can you solve this one? For the given shear force of a loading on a beam, what is the total downward loading here? What is the total downward loading? Can you solve this one? For the given shear force of a loading on a beam, what is the total downward loading? Can you do this one? See, you consider this section and you'll understand it. Suppose this is a beam. If you're standing at this particular location, you are getting minus of 22.5. When you will get that minus of 22.5? If you have upward reaction or upward loading. minus of 22.5, rotating about you in anti-clockwise. If you're standing at this location, you are getting plus of 27.5, plus of 27.5. What is that meaning of that? You are getting it upward, so that it will rotate clockwise. You are getting plus of 27.5. So this is actually simply supported with these two reactions. See, once I'll come to understand these two are the support reactions, which I'm getting 27.5 upward, 22.5 downward. Or see, you can do it in a two different way. Either you add these two, that's all, no, because all the vertically downward loading will be compensated by, or maybe, balanced by these two. Or just you check it out once again if you want to. So travel towards this side. If you are traveling toward this side, see, it is plus 27.5, which is upward. Now if you are coming down, if you are coming towards right side, this is, maybe I am considering right side, I'm moving towards this side, this is right side. If I'm moving towards right side here, if I'm reaching at this location, the load reduced 27.5 to, it is reducing by 20. So 20 downward, that too it is a UDL. Why? Because it has a linear variation. Now from here to here you have a constant, so no loading. At this location, as I'm shifting from this location to that location, the sudden change, the total change in a shear force diagram is 10, which is coming down. So 10 kilonewton is downward. Once again, if you are moving here, there is a change from 2.5 to 22.5. Once again, a 20 kilonewton is acting here. So 10 kilonewton is acting here, at 20 kilonewton is acting here. So total downward force here, this total amount is 20 here. This, I'm not writing down the intensity. It is 20 kilonewton over this length. If someone will ask what is the intensity, it will be 20 divided by length. So 20 plus 10 plus 20, it will be 50 Newton, right? It will be 50 Newton. A cantilever beam OP is connected to another beam PQ with a pin jointed as shown in figure. A load of 10 kilonewton is applied at mid. See, it is not about only this type of problem. He's asking what is the moment at O. The moment at O, how you will calculate? Always remember, whenever you have a hinge, always remember, draw the hinge. If it is provided, if it is loaded at this location, the beam PQ will get the reaction at P location from the another beam, right? From the another beam, which is OP. And now it will create a load over this OP beam at this location. This is the free body diagram. Now this is the reaction at P. Even if the loading is here and there, you calculate by considering it simply supported, and the reaction at P will be applied here simply. Now if it is symmetrical, it is quite easy to understand. 10 is there, so RP will be 5. 5 is acting here and the distance is 2. So 5 2s are 10. 10 will be applied here. So yes, a resisting moment or a bending moment, whatever you are asking, 10 Newton meter will be the, or kilonewton meter will be the moment at O. 10 kilonewton meter will be the moment at O. Are you able to understand that? A simply supported beam has a shear force diagram as shown in figure. Which of the statement is correct for the loading diagram? Can you identify? Which of the statement is correct for the loading diagram? See, it is written here, it is a simply supported beam. The best part is that he has written as simply supported beam. Now, if you know how to draw the shear force diagram, you obviously can identify it. Can you tell me which of them are correct here? Now, consider the section. Okay, just first of all, it is a simply supported beam. Nice to us. Simply supported beam. Okay, simply supported beam. Right. Now, for the simply supported beam, if you will consider the section here, just a moment, I'll take section here. Suppose if you are considering the section here, what is the meaning? You are having a minus of 23. When you will get the minus of 23? If you have upward reaction here, then only it will rotate about you in anti-clockwise. About you means you are standing here, no? About you, it will rotate in Anti-clockwise you'll get minus. Now consider the section here. Consider the section here. When you are getting plus of 25, if it is upward, then only you will get plus 25, because now you are standing here. So it is rotating about you clockwise, so it is plus 25, plus 25. Now if you are coming down from here, from A to maybe C, from A to C, the load changes from 25 to 10. So total change is 15. Total change is 15. So I can understand that it is linearly varying. So it is a UDL. What is the intensity of UDL? First of all, this is the reaction 23 here. This is the reaction 25 here. Now UDL intensity will be the total change. So slope of the shear force diagram will give you the intensity of the load. Now total change here is 15 over the length of 3. So the intensity will be simply 5. 15 divided by 3, 5 kilonewton per meter. Now from at this location C, there is a sudden drop down from 10 to 2. So there is a load, concentrated load acting there. There is a concentrated load 8 kilonewton. Total change from 10 to 2, that is 8 kilonewton is acting here. Right. Now from point C to B, there is a continuous variation. Once again, you identify what is the slope, because it is nothing but your UDL. So slope, if you are going to identify, see here, I actually don't know what is the length of this part. Length of, maybe consider DB length, I don't know, but I know the length of CB. So length of CB is known to me. I want the slope of this, because a continuous variation is there. There is a UDL. So length is 5 meter, and total change, if you see the vertical one, total change is how much? 23 and plus 2, that's 25. The total change here is nothing but 25 over the length of 5. So the intensity once again will become 5. Intensity once again will become 5 kilonewton per meter. He's asking 8 kilonewton is acting downward on the beam. Yes, correct. UDL of 5 kilonewton meter is acting on the beam. That is also correct. Reaction at support A is 25 kilonewton. That is also correct. All are correct. All are correct. Did you get that? Now what about this one? A simply supported beam has a shear force diagram as shown in figure. Which of the statement is correct for the loading diagram? Now consider this as a beam length as 10 meter. Beam length of the beam as a 10 meter. Which one of them are correct? And in between, please, it is a request, please do not forget to share and like. Please do not forget to share and like. Please like and share. So now once again, it is a shear force diagram for a simply supported. Now from the shear force diagram, he is asking which of the statement are correct here, or maybe what is it? Which of the statement is correct? Which of the statement is correct here? So see that now this is your beam, a simply supported beam. Consider the section here. If I'm considering the section here, I'm getting minus of 2. That 2 is in negative, no? When I will get the minus of 2, if I have a loading upward side, that is a reaction upward side, it will rotate about me. If I'm standing here, it will rotate about me in a anti-clockwise, so that I will get minus 2. Now considering the section at this location, when I will get minus 2, this is also minus 2. If I'll take the upward reaction, I will not get the minus, I'll get the plus. So it is not the upward one. It is the reaction is downward, isn't it? Reaction is downward. What is the value? That is 2. Now you see that you have a reaction 2 kilonewton downward, 2 kilonewton upward. In between you do not have anything else. You do not have any UDL. You do not have any concentrated load. Maybe there is a moment, because moment balancing has not been done yet. Right? If there is the concentrated load in between, you will find the sudden change. If there is a UDL, a linear variation will be there, but it is not there. So if you see that for over the length of 10 meter, you have a 2 and 2 in opposite side, you can say that now anti-clockwise moment of 20 kilonewton meter is unbalanced here, which must be balanced by some 20 kilonewton meter, clockwise moment. But that 20 kilonewton meter clockwise moment, you cannot identify where it has been applied. The application of the moment you cannot identify. Are you getting my point? The application of the moment cannot be identified here. For the shear force diagram, from the shear force diagram, you can identify the value of the moment which is acting on the beam. but you will never identify what is the position of that moment, right? Where it is acting. It only can be identified through the bending moment diagram. Are you able to understand that? Now, a beam is subjected to a concentrated load. That is totally correct. No, incorrect. Beam subjected to 20 kilonewton meter clockwise movement. That is correct one. That's all. That's all. Did you get that? What about this one? A simply supported beam has a bending moment diagram as shown in figure. Which of the statement is correct for the loading diagram? Which of the statement is correct for the loading diagram? Now once again he has written a simply supported beam has a bending moment diagram. Now bending moment diagram is given. He is asking about which one of the statement are correct or is correct. If you practice this way, nowhere in the shear force and bending moment diagram you will get trouble in your gate examination, right? Can you tell me which one is correct here? Now once again take your beam. Okay, I'm sorry, this is your 10 meter once again. This is your 10 meter. I'm sorry. This is your 10 meter. Length of the beam is 10 meter. This is your beam of 10 meter. 10 meter, right? Now bending moment in a simply supported, when you will get the zero. When you will get the zero, at these two places you have a zero bending moment. Means what? These two are the hinge locations, the end hinge position where you will get bending moment zero. Where you will get bending moment zero. Now you know that in a bending moment diagram the sudden change will be observed only when a moment is acting directly at that position. So a moment is acting, maybe consider that maybe a clockwise moment is acting. What is the value of the moment? How will you identify the value of the moment? The value of the moment is nothing but the total change there. Whatever the total change is from 6 to 14. See the way you have identified for the shear force diagram, whatever the total change you are having in a shear force diagram represents concentrated load. In a shear force diagram, whatever the total change you have represents concentrated load. Here, whatever the total change you have represents moment acting on the beam. So here total change is how much? From plus 6 to minus 14. That is total change 20. So 20 kilonewton meter is acting over the beam. Isn't it? Now if you are standing here, you can easily identify when you will get the 14. If it is 10, if it is 10. Now if it is 20 is acting over the 10 meter, you know that already that now. If it is clockwise, obviously the anti-clockwise 2 will act here. That is how they will compensate, no? If 20 kilonewton meter is acting over the length of 10 meter, reaction will be what? Net moment divided by length of the beam. Net moment is 20 divided by 10, you will get 2 and 2 here. That too, both of them will rotate in anti-clockwise if you have a clockwise moment. Now, if you have a 2 here, when you will get 14 if it is 7? If the distance here is 7, then only you will get 14 here. If the distance here is 3, then only you will get 6 here. That is 2 3 is 6. Are you getting my point? Now, check it out. He has written 20 kilonewton meter is acting on the beam. That is correct only. That is correct only. Moment is acting at 7 meter from the support A. That is also correct now. Reaction is 2 kilonewton. That is also correct. All are correct. Are you enjoying the session? Did you get that? Any doubt, please ask me. If you have any doubt, please ask me. Okay. Next one. Here. For the beam as shown figure, the distance to the point of contraflexure from the fixed end A is from the fixed end A. What is the distance of point of contraflexure from the fixed end A? How will you do this one? First of all, you should understand that it is a kind of prop cantilever. It is your indeterminate one. But here we do not have to worry about it. Why? Indeterminate, but already the reaction is given to us. So it is known. It is a known quantity for all of us. We don't have to worry about that unknown. Now, If you draw the bending moment diagram, then only you will be able to understand where the point of contraflexure is going to come. So over that beam, if you see here, this is the free end, zero bending moment. That's all. At B, you just draw the bending moment diagram here, right? Draw the bending moment diagram. At B, what is the bending moment? 5 into, at B, 5 into, distance is 0.25. And it is producing hogging moment. See here, it is producing hogging, that is negative 5 into 0.2, that is 0.75. 1.25. So here it is 1.25, right? And at this location, if you directly calculate what is the bending moment at A. So bending moment at A, if you write down, that is bending moment at A. What is the bending moment at A? See here, 5 into 1 is producing a hogging, then plus 8 into 0.75 is creating a sagging. What you will get? A plus of 1. So here you are getting plus of 1. Match these two lines. Now either you solve this with the help of similar triangle, or you solve it with the help of considering section. Now consider the section. Maybe from here to here x distance, because you know that somewhere here in between you are getting bending moment 0. Now bending moment 0, wherever bend, it's like changing the sign from plus to minus, that is your point of contraflexure. So you are actually searching for the point of contraflexure, right? Now at this section, if you write down the bending moment at section xx, bending moment at section xx, what it will be? See towards right side, 5 into, suppose if I have taken this distance minus of 5 into x plus 0.25, and then reaction, that is plus of 8 into x, that must be equal to 0. From here, if you calculate x, you will get almost around 0.42. But he has asked from A distance, from A fixed end A. From fixed end A, if you see that the distance is 0.75 minus 0.42, and you will find it is 0.33. If you have any doubt, please let me know. If you have any. Are you able to understand that? Now what about this one? The bending moment at A for the beam as shown in figure. What is the bending moment at A? What will be the bending moment at A? What will be the bending moment at A? Yes, Santosh. What is the bending moment at A? How will you calculate? This is very simple. Just take the section at A. Either you shift the load to the beam AB directly at this point, or you just see the line of action of the force, right? So if you are writing down the bending moment at A, the moment 20 is applied here, that 20 will create a sagging. So I will take plus of 20. Then 10 into 2 will create a hogging, that 10 into 2 minus of that, and you will get 0. That's all. It is 0 here. It is 0. Always see the line of action and multiply with the perpendicular distance. If you want to shift it, from shifting also you can understand it. From the shifting point of view, if you want to understand it, you can understand it. No problem at all. Shift that 10 kilonewton. From here to here. See, this is already done. If you want to shift it, you can shift it easily. From 10 kilonewton, you shift it here. If you are shifting it 10, what will come? 10 and 10 into 2. And 10 into 2 will be like this. That is 20 kilonewton meter. And 10. Now final beam, whatever you have, I'll just the load over the beam. Finally, this is your cantilever beam, and you have a load, that 10. Then see, 20 already applied here, and 20 you are getting it all together both. How much you will get? 20 plus 20, that is 40. 40 is acting like this, 40 kilonewton meter. From this point of this perspective, if you want to calculate, you can do that. Total distance is 4. Now bending moment at A. Calculate it. Bending moment at A. What will be the bending moment at A? 40 will produce a sagging moment, that is plus 40, and 10 will produce a hogging moment, that's 10 into 4 is the distance. Simply you will get 0. That's all. So either you do that like that, or you do like this. Both are okay. Sometimes they are giving that this type of diagram, and they're asking what is the bending moment. Maybe if you are going to apply the load here, maybe some 50 kilonewton you are going to apply here. What is this bending moment at maybe A? You see the line of action of the force. If the line of action of the force are passing through their point, no bending will be created. Or you maybe you shift the force or come here, then also you'll get the same thing. Are you able to understand that? Next one, the position of maximum bending moment from the lift support will be. What will be the position of maximum bending moment from the lift support here? What will be the position of maximum bending moment from the lift support? Can you do this now? So to get the maximum, position of maximum bending moment, draw the bending moment diagram. Or maximum bending moment. Do you have any idea? You will get the maximum bending moment where the shear force is 0. Are you able to understand that? You will get the maximum bending moment where the shear force is 0. If you want to draw the shear force and bending moment both, here actually first of all you need to calculate the reaction, which you will get almost 8 kilonewton here and a 2 kilonewton here. That I'm not calculating, you have to calculate it. Right. Now draw the shear force and bending moment diagram both. Draw the shear force and bending moment diagram both. If you draw the shear force diagram first of all, or this one, what you'll get exactly? See, stand here. One second. Okay. Just stand here by that. How 8 kilonewton is rotating about you? It is rotating anti-clockwise, so minus of 8. Then do not see in between the UDL. Just skip that until or unless not any of the load, any of the transverse load are acting in between the UDL. You skip it. Only see the end positions. Calculate what is stand here also. What is that? 2 is rotating about me in clockwise, so you'll get plus 2. Plus 2 you have to continue till this portion, and then in between you have a variation, linear variation. So if you see here, shear force is changing from plus to minus at this location. So this is the position where you will get the maximum bending moment, isn't it? Maximum bending moment will be you will be getting at this location. Here it is changing, so maximum bending moment will be here. Either you solve it through the similar triangle or just consider the section here. Consider the section X, take it from here, it is at X distance. From here it is at X distance. Maybe I will not hide this. Okay. Take it from the X distance, write it down shear force only. Why to see, he's asking what is the maximum bending moment, but while you write down shear force and equate it to 0, you will get it very easily. So shear force at section X must be equal to 0. Put it there. What is the shear force there? Summation of all the transverse forces, right? What is that transverse forces? 8 is acting, 8 is rotating about minus, so minus 8, then plus 5x, that's all. Must be equal to 0. How much you're getting? X will be 8 by 5, that is 1.6 meter. 1.6, that's all. That's all. Did you get that? Simply you'll get 1.6 meter. Are you able to understand that? Please let me know if you have any doubt. Please let me know if you have any doubt here. See, shear force and bending moment problems are easy if you practice more. And the clarity of drawing shear force diagram and bending moment diagram, if you have real clarity about all these two diagrams, you'll find that these problems of shear force and bending moment diagrams are very easy. So if you have any doubt related to conceptual problem, or maybe any problem if you are facing of anywhere, you just ask me in my Telegram channel, that is Civil by Ansari Sir. You do not forget, ask me there in my Telegram channel. Obviously you will get the answer, right? All of you, please watch the session carefully. We'll once again meet for the next session along with some fantastic problems. So study there in the app. That is the benefit of Champion Study Plan, isn't it? study from the app, and then you attend the question series. Then only it will be benefited to you. You will get the more maximum benefit from here. That Gate Champion Study Plan of Gradeup. Thank you everyone. That is the Gradeup Supers. All the structured live course and green card together you have. If you'll go for the super subscription, that's all for today. Do not forget to like and share once again. Thank you everyone. Oh, I'm sorry. I'm sorry. I just now have seen. You're saying that it is asking from left support. Okay, okay. I also have seen right now. Just now I have seen that comment. So left support. Okay, okay. That is okay. Just 5 minus 6. 5 minus 1.6. 5 minus 1.6. You'll get 3.4. Concept is same. Thank you. Thank you very much. Have a nice. Good night, everyone. Thank you.